Good day everyone. Today I will be reporting about oscillating systems and how we can relate amplitude, frequency, period, displacement, velocity, and acceleration. Before I start, here are the objectives for today's discussion. By the end of the lesson, you should be able to understand the physical significance of each quantity in oscillating systems, such as springs and pendulums. Relate amplitude, frequency, angular frequency, displacement, velocity, and acceleration. Grasp the definition and the relationships among amplitude, frequency, angular frequency, displacement, velocity, and acceleration in the context of oscillatory motion. An oscillating system is an object that moves back and forth repeatedly, returning to its original position after some time. This motion is called oscillation or periodic motion. For example, a pendulum swinging back and forth, a spring moving up and down. At the equilibrium point, the object has no net force acting on it. This is where the pendulum is at its center position and moves fastest. Maximum displacement from the equilibrium position. For example, the farthest distance the pendulum swings from the center. Amplitude. Maximum displacement from the equilibrium position. For example, the farthest distance the pendulum swings from the center. Frequency. Number of oscillations or cycles per period. For example, the pendulum swings twice per second. Period. Time for one complete cycle of motion. For example, if one swing takes 0.5 seconds, time equals 0.5 seconds. Displacement, the position of the object at a certain time. For example, halfway to one side displacement is less than amplitude. Velocity, the rate at which displacement changes. For example, fastest at the equilibrium point, 0 at the extremes. Acceleration, the rate of change of velocity. For example, strongest at the extremes, 0 at the center. Displacement shows where the object is. Velocity shows how fast it moves, and acceleration shows how strongly it's being pulled back. When the displacement is maximum, the object is at rest, so velocity equals 0. When the displacement is 0 or passing equilibrium, the object moves fastest to velocity equals maximum, acceleration equals 0. Acceleration always points in the opposite direction to displacement. It acts to pull the object back to the center. These show that the motion follows a sinusoidal pattern. The motion goes up and down smoothly, repeating again and again. These quantities don't reach maximum values at the same time. Velocity leads displacement by 90 degrees, while acceleration leads velocity by 90 degrees, and acceleration leads the displacement by 180 degrees. That means when displacement is its highest, velocity is already changing direction. They're out of phase but connected in a repeating cycle. Oscillating systems are all around us. Pendulums used in clocks, vibrating strings in musical instruments, shock absorbers in vehicles to reduce bouncing, and suspension in bridges experience oscillation due to wind or movement. So, oscillations aren't just in physics, they're part of our daily life, from sound waves to the movement of bridges. To wrap up, an oscillating system shows how motion repeats over time. Amplitude controls how far it moves, frequency and period control how fast it moves, and displacement, velocity, and acceleration show how the motion changes. All these quantities are connected and follow a smooth, repeating pattern.